Well, it was a spectacular night eruption at Mount Etna when lava met snow. We leave you with these images of lava illuminating the snow.
Europe's most imposing and volatile volcano, Mount Etna, unleashed a powerful eruption on February 12, 2025, propelling torrents of molten rock and towering columns of ash into the sky over Sicily. Beginning at 9:30 Universal Time Coordinated, this latest display of volcanic activity mesmerized both residents and visitors, offering a stunning yet sobering reminder of nature's immense power. Striking aerial footage documented the dramatic scene as fiery lava cascaded down the slopes from the Boccanuva crater, descending from an altitude of 3,000 meters to 1,900 meters. While no immediate threat to nearby communities has been reported, the relentless surge of magma underscores the unpredictable and formidable forces at play. Scientists continue to monitor the situation closely as the spectacle of glowing rivers of lava and billowing ash serves as both a visual marvel and a stark testament to the region's ever-present geological volatility. In the days leading up to the eruption, Mount Etna exhibited unmistakable signs of impending activity. A series of seismic disturbances, including earthquakes reaching magnitudes of up to 3.7 near the summit, indicated the underground movement of magma. These tremors, both a warning and a precursor, hinted at the eruption that soon followed. By February 8, glowing lava had begun emerging near the craters, accompanied by sporadic explosions signaling the volcano's growing instability. As conditions escalated, authorities swiftly responded. The Volcano Observatory Notices for Aviation, VONA, raised the aviation alert code from orange to red, reflecting the increasing danger posed by towering ash clouds. Local aviation officials grew concerned as the dense plume reduced visibility, resulting in flight cancellations and disruptions. While the eruption presented an extraordinary visual spectacle, it also underscored the volatile nature of Europe's most active volcano. Standing at approximately 3,330 meters, Mount Etna has erupted frequently throughout recorded history, with documentation dating back to 425 BC. Its fiery temperament has long captivated both residents and visitors, evoking a complex mix of awe and apprehension. Tourists flock to the slopes to witness the breathtaking contrast of glowing lava against the snow-covered landscape, a scene reminiscent of myth and legend. Videos circulated widely on social media, capturing the volcano's dramatic display. Yet, beyond the visual grandeur, the eruption posed real risks. Authorities issued health warnings regarding the fine ash particles in the air, which can cause respiratory issues and impact infrastructure. Towns near the volcano remain on high alert as officials closely monitor developments to safeguard local communities. The village of Lingua Glassa, situated on Etna's northern slopes, experienced intense tremors as the eruption unfolded. Residents were advised to stay vigilant, with scientists continuing to analyze seismic patterns to anticipate the volcano's next move. The uncertainty surrounding Etna's behavior adds an element of suspense as both scientists and locals remain watchful of its unpredictable nature. Despite the ever-present threat of eruptions, the region surrounding Mount Etna thrives, benefiting from the fertile volcanic soil that sustains vineyards and orchards. This duality of destruction and renewal defines life on the slopes, where generations have adapted to the volcano's cyclical temperament. Researchers are now focused on studying long-term patterns, as ongoing volcanic tremors suggest continued activity. The question remains, how long will this eruption last, and when will Etna fall silent once more? As lava flows persist and the sky remains streaked with ash, the world watches in fascination. Mount Etna's eruption serves as a reminder of nature's raw power, inspiring both reverence and caution. Through the lens of social media and scientific observation alike, this iconic volcano continues to captivate, standing as a formidable force on the Sicilian landscape. The unfolding seismic crisis in Greece has raised questions about whether it could have influenced Mount Etna's latest eruption. While the two regions are separated by hundreds of kilometers, they share a deep, complex connection beneath the Earth's surface. Both lie along the boundary where the African and Eurasian plates slowly collide, a collision that has shaped the Mediterranean for millions of years, giving rise to earthquakes and volcanic activity. Yet, despite this shared tectonic heritage, the idea that Greek earthquakes could have directly triggered Etna's eruption remains unlikely. Mount Etna's restlessness is primarily driven by forces deep within the Earth. Beneath its towering peak, magma rises from the mantle through fractures and chambers, accumulating pressure until the volcano unleashes its fiery wrath. Greece, on the other hand, is no stranger to seismic upheaval. The Hellenic Arc, a vast subduction zone, forces the African plate beneath the Eurasian plate, generating powerful earthquakes. Occasionally, major seismic events can redistribute stress across vast distances, subtly altering fault lines and underground reservoirs of magma. In rare cases, this shifting of forces can contribute to volcanic unrest. But the chain of events required to link Greece's earthquakes to Mount Etna's eruption would be intricate and unlikely in the short term. At the heart of this mystery lies the nature of seismic waves, the invisible shock waves that ripple through the earth each time a fault line ruptures. When an earthquake strikes, it sends out P waves, primary waves, which move the fastest and compress the ground like a slinky. These are followed by S waves, secondary waves, which shake the ground side to side, causing much of the destruction in major earthquakes. Beyond these, surface waves, which travel along the Earth's crust, can reverberate across vast distances, even subtly disturbing other geological systems. It is these waves, particularly long-period seismic waves, that have the potential, however slight, to affect a distant magma chamber. Could these seismic waves have disturbed the molten rock beneath Mount Etna? Theoretically, if an earthquake in Greece was powerful enough, it could have sent low-frequency seismic waves propagating through the Earth's crust. These waves can alter pressure within magma chambers, potentially destabilizing a system that is already on the brink of eruption. In other cases, strong ground shaking can fracture rock, creating new pathways for magma to rise. However, for this to happen, the earthquake would need to be exceptionally strong, likely a magnitude 7 or higher, and interact with pre-existing weaknesses in Etna's magmatic system. Still, the Mediterranean is a region where history has repeatedly shown that Earth's fury knows no borders. Past patterns reveal instances where heightened seismic activity coincided with volcanic unrest, leaving scientists to wonder if these events are part of a greater unseen mechanism at play. The notion that one disaster could whisper to another across the vast subterranean networks beneath Europe's most volatile regions is a haunting one. Could the violent tremors beneath Greece have sent invisible ripples through the tectonic plates, subtly nudging Etna's already unstable magma system toward an eruption? For now, the answer lies within the data. Volcanologists and seismologists are carefully monitoring ground deformation, seismic waves, and gas emissions from both Greece and Mount Etna. The science remains clear: Etna is one of the world's most active volcanoes, with eruptions occurring frequently regardless of external influences. But beneath that clarity lingers an undeniable truth: the Earth is alive, unpredictable, and intricately connected in ways we may not yet fully understand. The restless forces beneath Greece and Sicily remind humanity that we are merely spectators to the grand, untamed power of nature, watching as fire and stone shape the world beneath our feet. Throughout history, Earth has repeatedly demonstrated its ability to unleash devastating power in ways that defy human understanding. In many cases, massive earthquakes have been followed by volcanic eruptions, raising questions about whether these forces are connected or simply coincidental. Although the mechanics of such interactions remain a subject of scientific debate, past events suggest that seismic upheavals can, at times, shake the very foundations of volcanic systems, awakening long-dormant giants or accelerating unrest already brewing beneath the surface. One of the most striking examples occurred in 2004 when a colossal magnitude 9.1 earthquake off the coast of Sumatra sent shockwaves through the Indian Ocean. Known primarily for the devastating tsunami that followed, this event also coincided with increased volcanic activity across Indonesia. Mount Talang, a restless peak, erupted just months after the quake, and other volcanoes in the region showed signs of unrest. The possibility that seismic waves had disturbed magma chambers beneath these volcanoes intrigued scientists, leading them to examine whether the earthquake had subtly altered the underground pathways through which molten rock flows. The concept of seismic waves, specifically long-period waves, continues to be a subject of intense study, as researchers seek to unravel the mysteries of Earth's interconnected forces. Waves capable of traveling great distances became a crucial focus in understanding how one catastrophe might set the stage for another. A similar phenomenon unfolded in 1960 when Chile was rocked by the most powerful earthquake ever recorded, a staggering magnitude 9.5 event. The immense rupture sent seismic waves radiating across the planet, triggering landslides, tsunamis, and even measurable changes in Earth's rotation. But 2 days after the quake, something else happened. The Puyo-Cordon-Col volcanic complex erupted violently. The timing was impossible to ignore. Some researchers believe that the earthquake's massive energy release altered the stress dynamics beneath the volcano, opening new fractures through which magma could rise. If true, this event served as a stark reminder that Earth's seismic and volcanic systems are deeply intertwined, bound together by forces operating on scales far beyond human perception. More recently, in 2011, Japan experienced one of its darkest days when a magnitude 9.0 earthquake off the Tohoku coast sent towering tsunami waves crashing into cities, claiming thousands of lives. In the aftermath, something strange occurred. Mount Shinmodake, a volcano in the Kurashima Range, erupted with renewed intensity. Although it had already shown signs of activity prior to the earthquake, its behavior changed significantly afterward. Scientists theorized that the immense ground movement had caused subtle shifts in magma chambers deep below the surface, altering the pressure dynamics that govern eruptions. This event added to the growing body of evidence suggesting that major seismic activity has the potential to act as a catalyst for volcanic unrest. But perhaps the most haunting example of all is the 1707 Hoi earthquake in Japan, a magnitude 8.6 disaster that devastated the region. Just 49 days later, Mount Fuji erupted in a violent display of fire and ash, the last major eruption in its long and storied history. For more than 300 years, Fuji had remained dormant. Yet, something about the earthquake appeared to have disturbed its slumber. Did the immense shaking destabilize magma reservoirs beneath the mountain? Did fractures in the crust open new pathways for molten rock to reach the surface? Even centuries later, the precise mechanisms remain a mystery, but the eerie timing of the events continues to fuel scientific inquiry. On February 13, 2025, seismic activity in the Santorini region remains ongoing, with 1,396 earthquakes recorded in recent days. The latest data indicates a magnitude 2.8 tremor near the northern edge of the earthquake swarm overnight. Larger quakes have also been observed, including a magnitude 4.0 and a 4.7, suggesting that the region remains in a state of heightened unrest. While the overall frequency of smaller quakes appears to have diminished, the presence of these larger tremors indicates ongoing subsurface pressure buildup. Recent seismograph data has shown intense activity over the past 2 weeks, with clear signs of magma movement beneath the surface. The recorded earthquake depths, averaging around 10 kilometers, suggest that this pressurization is occurring at a significant depth. The pattern of seismicity points to a phase of increased magmatic intrusion, reaching a critical threshold of pressure approximately 6 to 7 kilometers below the surface. This could lead to another surge in seismic activity, or there may be a temporary period of relative quiet before renewed unrest. The situation in Santorini bears some resemblance to recent events in Iceland, though the geological settings differ. While Iceland sits on a continental rift zone, Santorini is part of a complex volcanic system featuring numerous submarine volcanoes, including the Colombo volcano. The seismic activity has shown a trend of migration southward toward the Santorini caldera, raising concerns about potential volcanic activity in the region. The earthquake swarm's central core is experiencing intense pressurization, with surrounding fractures suggesting considerable underground swelling. While direct measurements of seafloor displacement remain unavailable, the limited functional seismographic station on the eastern edge of the Santorini volcano provides critical insight. No operational instruments are currently detecting activity across the Morge or Colombo volcano regions, leaving gaps in precise monitoring. Recent data reveals substantial vertical displacement with a pronounced upward trend over the past month. This pattern strongly suggests ongoing inflation beneath the area, particularly to the northeast of Santorini, with some seismic migration toward the southern volcanic system. Although a temporary decrease in earthquake frequency has been noted, the presence of larger tremors, including a recent magnitude 3.6 event, suggests that pressurization remains a driving force. The expectation remains that the subsurface magma will eventually breach weaker rock layers, resulting in continued fracturing and seismic activity as it seeks a path toward the surface. Inflation and seismic swarms of this magnitude are typically associated with magmatic intrusion. Though the timing and nature of any potential eruption remain uncertain, it is possible that activity may subside temporarily before resuming with renewed vigor, as has been observed in other volcanic systems. The latest seismic data suggests that the region is approaching a critical threshold of pressure, which could lead to further instability. Despite a temporary lull in smaller tremors, the sporadic occurrence of larger quake signals continued underground pressurization. The absence of microseismicity could suggest a shift in the stress distribution beneath the surface, making future developments uncertain. While it is impossible to predict the exact outcome, the sustained influx of magma suggests that this activity is unlikely to subside entirely. Seismic activity over the past 24 hours has remained within a moderate range, with the most significant earthquake, a magnitude 5.3, occurring in the South Sandwich Trench. Today's largest recorded event has been a magnitude 5.0 in the Banda Sea region near Indonesia. While there has been some seismic movement near Japan, activity in that area has remained relatively subdued, aside from a single magnitude 5.0 event. Further north, off the coast of Russia, a magnitude 4.3 earthquake was detected early this morning. The clustering of tremors around the Indonesian islands continues to follow typical patterns, while regions such as New Zealand and the Fiji area have remained unusually quiet, aside from a shallow magnitude 4.9 along the western coast of the Americas. Seismicity has shown slight increases. The Middle America and South American trenches have displayed a moderate uptick in activity compared to the previous day, though most events have remained within the magnitude 3 to 4 range, which is typical for these regions. In California, a magnitude 2.7 earthquake occurred along the Hayward Fault, a system known for its significant seismic hazard due to its proximity to densely populated areas. The fault has long been considered overdue for a major event, making even minor tremors in the region noteworthy. Northern California, particularly near the Petaluma region, saw some heightened activity yesterday, including several magnitude 4.0 earthquakes. Though recent activity has declined, the latest recorded event was a magnitude 3.1. Meanwhile, Southern California has remained quiet, with only minor microseismicity detected. Further inland, Nevada has experienced a small swarm of earthquakes likely linked to ongoing tectonic strain along the plate boundary. In Yellowstone National Park, seismic data from monitoring stations indicate no significant earthquake activity, with only minor environmental interference, such as wind-related signals, appearing on the records. The region remains stable for now. Texas and Oklahoma, regions known for their induced seismicity due to oil extraction and fracking operations, have experienced increased activity today. A notable earthquake further south in Texas has raised interest, though satellite imagery does not indicate any nearby fracking sites. In contrast, the northern portion of the state remains densely populated with oil fields where earthquake activity is frequently linked to subsurface fluid injection. The presence of seismic events in these regions continues to reflect the complex relationship between industrial activity and natural fault systems. In the central United States, a magnitude 2.4 earthquake was recorded near Jackson, Tennessee, just outside the New Madrid seismic zone. A review of the past 30 days of activity in the New Madrid region shows approximately 23 recorded earthquakes, consistent with long-term trends. These small tremors serve as a reminder that the region remains seismically active despite the absence of large events. While no immediate threat is indicated, the New Madrid Fault remains one of North America's most significant seismic hazards. A magnitude 3.0 earthquake was recorded off the northern coast of Hawaii at a depth of 14 miles. This event is likely related to ongoing tectonic stress along the Pacific Plate, but does not indicate any significant seismic activity in the region. Kilauea volcano, which recently experienced a brief eruption, has entered another pause phase according to the latest update from Hawaii Volcanoes National Park. The sun eruption remains inactive, though another episode is anticipated within the next 3 to 6 days. This pattern has repeated multiple times, making the next eruption the 10th in this ongoing cycle. Ground deformation data reveals a familiar trend. Following each eruption, inflation occurs as magma accumulates beneath the surface, only to be followed by another eruption and subsequent deflation. This cycle has persisted for weeks, indicating a steady magma supply unless a blockage develops within the crater, which could redirect magma to a different location. This pattern is expected to continue. In the realm of space weather, solar activity remains relatively low. Current sunspot observations show no significant areas of magnetic complexity, with most regions appearing neutral. A potentially active sunspot is emerging on the Sun's northeastern limb, but its structure remains unclear at this distance. The likelihood of a major solar flare remains minimal, with an estimated chance of less than 1% for an X-class event. Meanwhile, the probability of an M-class flare stands at 5%, while overall solar wind activity has introduced only minor fluctuations in geomagnetic conditions. No significant auroral storms are forecast at this time. If you found this update insightful, don't forget to like, share, and subscribe for real-time coverage of Earth's most powerful natural forces. Stay alert, stay informed, and I'll see you in the next video.